Write the equations for the preparation of 1-iodobutane from tang tang tang. Well, 1-iodobutane from butanol. Now I have 1, 2, 3, 4. This is 1-butanol. And I want to convert this to 1, 2, 3, 1-iodobutane. What do you think I would need to do for this? Well, I also have 1-chlorobutane which I intend to convert to 1-iodobutane, and I have but1-ene which I intend to convert to 1-iodobutane. How shall I do it? Well, let's take a look. Now, when you look at question number 1, there are, well, two very interesting roots. What is that? See, first of all, notice what exactly is happening. You are substituting OH by I. So, it has to be a substitution, right? Not just that, I would be available as I plus or I minus, it would be available as I minus. So, it seems like nucleophilic substitution, and this is primary carbon. Now, if you want primary to primary, it clearly indicates SN2 mechanism, and by SN2 mechanism, if I am doing a substitution, this is nucleophilic substitution, we are using nucleophile as I minus. So, what could have been a possibility? One possibility could have been just use HI. What happens? There are two steps. You have alcohol plus HI. Please note, we should not have hot conditions, otherwise there would be a problem. Cold is good enough. And oh wow, what happens? H plus is donated here, and I get OHH plus like this. Oh wow. Now, please note OH minus. If OH minus is pushed out, OH minus is not a good leaving group. But now I have, first of all, I have free I minus. I minus is a great nucleophile, yes. And at the same time, now H2O would be a good leaving group. So, if there is an attack now, attack. This is a classic SN2 attack. And if this pushes out H2O, I would get what? I would get something like this. Oh wow, this is 1-iodobutane, yes. And I get H2O, yes, very much. Is it a good method? It's a beautiful method with one limitation. What? Although this might not be discussed in NCERT, but you should be aware that if you heat it and if this cation departs on its own without this attack, then there might be a component of SN1 mechanism as well. If you heat it, portion of SN1 will increase, there will be added complication of rearrangement which will be very unpleasant. So, just make sure that you are using HI and this is conducted at low temperatures only, and you would get very happily 1-iodoethane. Could there be another method? Yes, I am giving you, this is a very simple common method, I am giving you that. In addition, I am also offering you a beautiful alternate method as well. This, my dear, is a method called acetylation. See, the problem is, approach it like this, we are converting, now this is a poor leaving group, and this poor leaving group has to be converted to a good leaving group. One method was use HI, add H plus, and you can do that. We saw that. I am giving you a second method. This is method 2. And this method 2 will have better yield and less drastic reagents. And this would be, treat this with ClCOCH3. What is this? This is acetyl chloride. Wow, what happens? You would find that once they react, this HCl goes away and you would have O, yeah, and this O gets attached to COCH3 like this. Now, this is no longer OH, this is OCOCH3, and this entire group is now a good leaving group. Lg is leaving group. And now, in the second step, you treat this with, in the first step you add this, in second step you add Ki. Oh wow. Attack. Classic SN2 attack. And this is pushed out. And what do you get? Well, you get CH3, COO minus, which is pushed out, and 1 iodobutane. I am giving you not one but two methods of this preparation. Now, starting with 1 chlorobutane, I have to prepare 1 iodobutane. 1, 2, 3, 4. 1 chloro, you're giving me 1 iodo. This is not at all difficult. Finkelstein's reaction. Ki in acetone. When you add this, you find that there would be substitution. KCl will simply precipitate out and you get all chloro or bromo halides can be converted to iodohalides by using Ki in acetone, the classic Finkelstein's reaction. The second is very easy. Is there a mechanism involved? It is not asked, but it is classic SN2 in case anybody is interested. And the third one is but1ene. Wow. I have from 1 butene, I am supposed to get 1 iodobutane. Now what happens if I add simply HBr or HI to this? If I just add HI, let me add HI and let me see what do I get. If you add HI, first you would get H added here, carbocation here, Markovnikov's rule, and you would have H and I like this. So you would get 2 iodobutane. If you simply add HI, you get 2 iodobutane, which is something which you don't want. Yes. So is it a good idea? It is not a good idea to add HI directly. Then what should I do? I need anti-Markovnikov addition. And anti-Markovnikov addition, is it crash? I mean, we call it crash, right? No, there is a scientist also called crash. Crash effect. You use first HBr and you use peroxide. So this would give you anti-Markovnikov addition. You get H here and Br here. 1 bromobutane. And now you use Finkelstein's reaction. Ki in acetone in the second step. And Br changes to I and you get a nice happy precipitate of KBr. Done, 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 done. Right? 2 steps like this. This would be an appropriate conversion.